Witajcie wszyscy, znowu mamy dzisiaj gościa, więc dzisiaj troszeczkę innym layoutie, bo inaczej żeśmy się dołączali do tego spotkania, ale mamy dzisiaj z nami Mike'a Liebermana z Kusari, który opowie nam troszeczkę o platformie. Ja będę rozmawiał z Mike'iem o nudnych rzeczach, potem Rafał skoczy na głęboką wodę i będzie cisnął. Ten podcast będzie po angielsku, ponieważ nasz gość, nie będziemy męczyć naszego gościa zmuszaniem uczenia się polskiego. Natomiast postaramy się zrobić polskie napisy, więc jak komuś przeszkadza język, to postaramy się zrobić to w wersji kinowej. I cóż, zapraszamy do wysłuchania naszego podcastu.
Dokładnie, zapraszamy serdecznie i jak coś prosimy bardzo o komentarze, one zawsze nam bardzo, bardzo pomagają.
Subskrybować, lubić.
Dokładnie, nawet jak macie jakieś pytania, to dawajcie znać, my je przekażemy dalej i odpowiemy też w komentarzach.
Tak jest.
Co, jedziemy. Let's start.
Okay, yeah, so we change the language now to the proper one, right? So welcome, Mike, again. As I said, we have our special guest today, Mike Liebermanem from Kusari, and we will talk about Kusari, what you are doing, how you are doing, what problems you have, or maybe you don't have any problems. That might be problematic, but anyway. But first thing I would like to ask you why you had this idea, right, to create Kusari, because there is a lot of security platforms already, right? So what was the difference?
Yeah, sure. My background, early on, I was DevOps engineer, doing a lot in a couple of different companies, from sort of media companies to startups in sort of like the advertising space. And then eventually, ended up in financial companies, like at hedge funds, banks, those sorts of things. And one of the things, especially at the banks, that I had noticed, and also one of my co-founders, who I was also working with, Tim, had also noticed, is like, hey, there's a lot of problems we were running into with dependencies, right? The third-party risk, as they call it. Where external sort of dependencies, whether they're open source dependencies like Log4j, or if they were like a vendor provided thing like a SolarWinds agent or something like that, you're like, okay, well, where does, how do I know what's actually in my ecosystem? What are the issues that I run into? And a lot of times, especially at the banks, you get a lot of those, they're not like ongoing things that people know about. It's, you are about to do a big deployment and you get a tap on the shoulder saying, hey, there's a problem there. You're using Log4j somewhere and you find out that you're not using it, but your VM image is using it or something like that. And so we kept running into these issues. And then similarly, the other co-founder, Parth, did the same thing. He was working at a bunch of different government contractors in the US, and it was the same sort of problem. And so we had built a bunch of custom solutions at a lot of the different places we were working at to help sort of identify where there are, where these dependencies live, where are they in your ecosystem? Do you have, is this, if you do have the Log4j, Log4Shell vulnerability, is that only in dev? Is it in production? If it is in production, is it externally facing? So we kept building like all these custom solutions, and we realized, like, why don't we just all get together and try and build something ourselves and build a platform that we can then provide to anybody who wants it. And so that's why we created Kusari.
All right, thank you very much. That's an interesting story, really. And I see also what you didn't mention is the licensing kind of scanning, right?
Yes.
I am one of the people behind OpenTofu, so I know about licensing a little bit. So that's why it grabbed my attention immediately. In this case, you've created the platform. So what was the decision behind going with the SaaS platform? Because, of course, today, SaaS is the most popular one, right? And we know the obvious thing, like, yes, your team doesn't need to have the, ability to manage the stuff. You don't need the infrastructure. You don't need to pay that much, but you have to pay to the platform, yes, and so on and so on and so on still. And still you need someone who will manage this platform, right? So what was the pros and cons for the SaaS for you?
Sure. So there's always going to be a trade-off between the different customers, right? Some customers, they don't want SaaS. They want to run everything internally. Some of the enterprises out there, they're like, no, we can't have this data go outside of our environments. We need all of it in. And then some folks are like, hey, I don't want to run all of that myself. And there are a lot of different components. So I think, there are a lot of trade-offs. Some of it is just the nature of the industry where, hey, SaaS is a known quantity. Like, people know how to sell it. People know how to do that. Whereas if you're coming in and saying, hey, we're selling, this all-in-one thing that you deploy yourself 100%, it can be, a little bit more complicated. Now, with that said, we still, obviously the majority of our stuff is SaaS, but we are still having those conversations with the larger enterprises for things that we can deploy in those environments as well. But I think the thing with SaaS is it's also easier just generally on us as well. The big thing with and as somebody who's used to work with a lot with OpenShift and a lot of other things is like when you have your rels, your OpenShifts and all those things, one of the biggest issues that folks bring up is like, as the maintainer of a thing like that, somebody comes in and is like, well, I'm using, Acme Corp, program X version 1. And you're like, well, we're already on version 1.3. We don't want to support version 1 anymore, but the customer's still paying you and yada, yada. And they don't want to upgrade because they're like, well, we only do yearly upgrades and we only do, yearly patching for these sorts of things, unless it's a major security vulnerability. And so now your company isn't just sort of managing one piece of software. You're managing lots of different, sub pieces of software. So there's a lot of, it's much easier on our end for a lot of that. And, the other thing too, right, we have fantastic infrastructure engineers here at Kusari who, again, they can set up the various infra as code that we use, right? They can set that all up and like, hey, an upgrade or a new deployment is a single command, and they can use all the resources in AWS, in Kubernetes, and whatever else that they need without necessarily needing to do any sort of manual steps. But it's also very much baked into, hey, we use AWS Lambda here, and we use AWS step functions there, and we use, Fargate here and EKS there and whatever else, right? So for a lot of folks, that's going to be, they're like, well, we don't use Lambda. We don't allow Lambda. It's like, okay, well, we can figure out another solution, but one is like the SaaS is like, hey, it's a single click for us to deploy a new tenant, but for, custom tenants, hey, that's going to require a lot more effort.
Yeah, perfect. And I think, Rafał, you catch a couple of elements which you already want to ask. So the last question from my side, because then you will go to the more interesting for our audience, topics more interesting for our audience. So I have a question about, you mentioned your background is also DevOps, right? So this is the obvious question about CI/CD, how it works, how Kusari works with the CI/CD pipelines, and
Sure.
what is your offering here? Because of course we can find it on the page and read it and so on, but when you will explain it, it will be much better.
Sure. So so to take a step back, a lot of my background actually was in CI/CD, specifically with sort of DevOps. And so I co-led the Secure Software Factory reference architecture for the Cloud Native Computing Foundation, the CNCF, where we were talking about like, what would it take to make a real secure CI/CD system? And actually one of the first things we had sort of built in the open source, and this is when a bunch of us were still at companies like Citi and Boxboat and similar, we created a project called Fresca, which ended up landing underneath the OpenSSF, the Open Source Security Foundation. And so we had a lot of background there. Now, again, I think the big challenge for like, why build a SaaS platform for organized, these sorts of things? Why not focus on selling a CI/CD platform? It turns out a lot of folks don't want to move off of Jenkins still. And no matter how much you tell folks like, hey, there's a lot of security concerns with running Jenkins, you really need to do a lot to secure it, a lot of folks are like, that's a rat's nest I don't want to touch. So,
Oh, yeah.
but with that said, the folks who don't have to worry about that are folks like ourselves who are like, hey, we can go and build a lot of that stuff out ourselves. Now, so for us, there's a couple of things, right? So right now we're at the point where we can mostly get away with using sort of GitHub for the majority of the build, so GitHub Actions. But with that said, we still use, Salsa, which is an OpenSSF project, which I'm also a maintainer of and on the steering committee for, which for folks who aren't super familiar, Salsa is supply chain levels for software artifacts, which is essentially just a set of practices by which you build your software, a series of security best practices by which you build your software. So to help you understand, hey, did this source code actually lead to this artifact? Whether that artifact is a Go binary, a Java jar, container image, whatever it may be. And it's about provenance. So it's about trying to make sure, hey, do I have a good understanding that this actually led to that? Because then if something went wrong, you know what went wrong. It must have been in where the build was. So we use stuff like Salsa. Other things that we've used in the past, again, that I think is super valuable is things like, when I think about CI/CD and I think about securing it, the main things I think about are, one is I want to secure the overall workflow. Like, what is the actual people who are designing the build processes? What are they allowed to run? So if my company says, hey, we don't use Python, great. If you come in with a Python build, we should just fail it immediately and say, sorry, you're not allowed to run this. And the same thing goes with like a particular version of Java or a particular version of a thing. Or, hey, did you know that your job doesn't have a SAS scan? We're not going to run it unless you have a SAS scan in the job. So that's kind of one thing. And then the second thing that you're trying to essentially protect is you want to make sure that the build system itself, the control plane for that build system, so like how it's actually orchestrating, an admin to that can't like falsify what it's doing. So one of the challenges, especially on Kubernetes, is an admin to the Kubernetes cluster could come in, swap out the image in a pod while it's running and tell it to do something else. And you're like, oh, I thought it was running make. And it turned out it was actually running, curlmalware.com or whatever. And that's really hard to sort of identify. And then finally, the third thing is, even if, let's say, those two things are secure, you want to make sure that the software build, right? Hey, you're using an image, your Go build, your version of make, whatever. Is there something suspicious there? Can we essentially record what's happening in the build to understand, is it trying to reach out to the network and do something suspicious? Now, again, those things all have, like everything I just mentioned there comes with costs. So you might not want to do that for your marketing website where you're like, if somebody compromises this, it's bad, but it's not like the same as somebody compromises, our external facing banking application, right? Like that's where you would spend all the time and effort to really harden that. And then, you'd still do some reasonable things for everything else.
Yeah, so I said already that will be my last question, right? So I lied. Because I have one more. Because it's very interesting. You mentioned CNCF and so on, because we spoke a lot about CNCF. We are around, let's say. So it's great to have like a fellow open sourcer. But last question from my side, and this time I promise last question in this part.
Take your time, don't worry.
About SBOMs and all of this around. So for those of you who don't know what SBOM is, it's the software bill of material, and it means that all components which are in the software, right? All components, all dependencies, all stuff like this. Every information about this, maintainers, vulnerabilities, versions, licenses, everything, right? So in one question, I have like two parts. First of all, did you select any approach like Cyclone DX or SPDX, and how do you generate it, and what? Because generation is only one thing. So what next? What we can do in the Kusari platform with what we generated?
Sure. Yeah. So, Kusari platform supports both Cyclone DX and SPDX. With that said, I think there's The challenge is it depends on the ecosystem. Like for certain ecosystems, SPDX is a little bit better. In a lot of other ecosystems, CycloneDX is a little bit better. There's also, and I want to stay out of the a mudslinging fest between the two sides, because there is a lot of controversy between the two sides. Like you talk to everybody's very friendly, but there's clearly they each want their own side to win a little bit to be the most adopted thing. And I think, if I were to have one sort of suggestion to both sides, is I think that really hurts the overall consumer. And I think that there is opportunities and to collaborate on different things. Like the thing I've noticed is, CycloneDX has a lot in there. And that can be also a problem for somebody who's building the tools, because as somebody who's building the tools, there's so many options out there, but a lot of our customers are like, we're using these 3 optional fields, but not those 2, not these other ones. And so when you're trying to support somebody, you're like, wow, there's a lot I need to I need to support everything, because everybody has different optional things they want. SPDX is a little bit different there. And they're a little bit more sort of constrained, but they're also, in my opinion, also a little bit more academic. They're very focused on, their ontology and using things like OWL and Shackle, and that can also be difficult to sort of integrate with. So with that said, we sort of use both. We found that generally, I would say CycloneDX tends to be a little nicer to use in most cases. Again, 60-40. It's not like, oh my gosh, CycloneDX blows everything else out of the water, or SPDX has all these issues. It's like they both have different issues, and we hope that folks sort of come together. And we actually think that the bigger issue is sort of what you described, is like pulling in all the dependencies, because it's more about where the SBOM is built and how it's built than necessarily the individual sort of specification. And the thing that we run into a lot is, when I get an SBOM, I don't know what type of SBOM you're really, like, what are you trying to actually tell me with this SBOM? Is this purely an SBOM for this binary and its dependencies? Is it an SBOM for the entire virtual machine or container image it lives on? It can be very difficult to know, just sort of looking at the SBOM, unless there's additional metadata in there. And for us, obviously, the more data you can provide, the more insights we can provide there. And the thing that we want is better linking between things, so that we know this container image contains this Go binary, and this Go binary points to this SBOM over here, right? Like where you can then look at the SBOM there, so that you don't have to necessarily have a gigantic SBOM unless you need it, right? Like if I'm sending you one SBOM, great, take the 5 different SBOMs, throw them, combine them all together to kind of give somebody. And then that also makes it very easy for us to then, again, look at vulnerabilities. We link everything in our platform, and that helps us with stuff like, again, like vulnerabilities and certain other things like that are temporal, right? They're going to come up as they come up. So SBOMs will need to be either modified, or you need to have something like the Kusari platform that keeps track of all of that, and then says, hey, you are using, this Acme Corp product, and they told you that they're using this library. And hey, that library now has a vulnerability we discovered, right? But then the other thing that this all allows for is, because we can integrate with all these other data sources like your runtime data and other things, we can say, well, but it's only running in dev. So maybe it's not like the most immediate thing, or no, this is externally facing, this is in your production system. It has access to all your customer data. You should probably fix this right now. And so those are the sorts of things I think that like really helps out when you have a good SBOM is, the exact composition of the software should not change, right? Unless you get like a better understanding of the software, that should not change. Licenses generally should not change either, right? They're usually static. And even if somebody does do a rug pull, they usually can't retroactively make an older version of the code or whatever, like under a different license. But as long as you're doing all those things, I think you can kind of get really good stuff out of it.
That's true, and it's not only about the vulnerabilities, but also about the exploitability of this vulnerability, right? So this is very important. So thank you for touching this, because this is a very, very important element. Rafał, now your turn, and I'm just be quiet.
Okay. Well, thanks, Paul, and thanks, Mike. Well, regarding that stuff you guys said, there's one thing. It is also important to mention that it really depends from whom the package comes, because we can fetch the package from PyPy, for example, but we can fetch the same package from something else, and we'll see in setup Pi or somewhere else in dependencies, but there might be something totally else. And that's what actually Guac helps us to find out. And maybe if you could tell us how Kusari works, how it packages the Guac, and actually what Guac is.
Sure.
That would be great, because I will be honest with you, before our meeting, I've heard about Guac maybe a few times. I have never implemented it. And to be honest, I believe SBOMs and software supply chain management is totally new thing in Poland and EU. I haven't heard about that very, very often. So it's totally fresh market. Please open minds, everyone. And well, right now, the stage is yours. Could you explain to us why we should take care of our supply chains, and why we should use Guac and Kusari?
Sure, yeah. So let me start with why is supply chain important, and then I'll kind of go into some of those other things. So I think there's like two main reasons why supply chain is important. One, so the one is just like, you want to know what you're actually running, right? When you buy a car, the car manufacturer knows every bolt, every piece of the engine, every every tire, every wheel, everything that's in the car. They know where it came from, and they know who provided the metal, who provided the screws, who provided all these different components to it. And the reason why is it makes it if anything were to ever go wrong, they could always recall the car. They know what would need to be repaired. So there was like a big issue, I want to say 15, maybe 20 years ago at this point, with airbags that came from Japan, right? There was they called it Takata airbags. They were these airbags that were defective, and they were installed in, I think, hundreds of thousands of cars. And, they had the tendency to potentially either not go off when they needed to go off, or in certain cases, they would go off when they shouldn't have gone off, when somebody's just driving normally. And like, that is kind of the thing when it comes to the software you're using. Like Log4j, that there was that big vulnerability in 2021, I believe. And that vulnerability, when that came out, people just didn't know where that was living, right? They didn't know, do I have that in one place? Do I have that in 100? Am I using it directly? Because, if you're using Maven or Ant or any of the other sort of Java tools out there, if you have like your Maven file, you can look at it and say, oh, I'm not using Log4j. It's not in there. But then when you actually run everything, you're like, well, actually, I'm using Spring, and Spring uses Log4j.
Yeah.
And that can go 3 or 4, 5, 6, 10 layers deep before you realize, oh, actually, this is a big vulnerability there. And so that's like a huge problem. So when you kind of go in, you're like, hey, I don't think I'm using anything bad, but you don't realize, because you're not actually building an inventory of all these things. And I think if all of us take it more seriously, it becomes easier, because then you can have folks saying, hey, I'm building these 5 components, and I hand you an SBOM. And now you could say, well, I take those 5 components, combine it with these other 5 components. And, you're kind of building up this sort of thing where you say, okay, here's my entire platform, here is the SBOM for that. So that's one big reason. And then tied to that is the governments out there are recognizing that this is a big issue, right? That a lot of companies aren't taking this seriously. And as seriously as I would say, car manufacturers, medical device manufacturers, which are taking this very seriously, because as you can imagine, a pacemaker or similar for, if something goes wrong in a pacemaker, somebody could die, right? And so if there's a vulnerability there, you need to know. And so so for example, the EU has the Cyber Resilience Act, which goes into full effect in 2027. But there are parts of it that are going into effect slowly but surely over time. And that thing, the companies who sell in Europe will be required to do things like software bill of materials. They'll be required to do certain security things for their supply chain. And some of those things will be, standardized stuff. And it depends again on what you're building, right? If you're selling a video game, it's going to be a little bit less stringent than you're selling a hardware security device. A hardware security device is going to go under more intense scrutiny, third-party audits, those sorts of things. You're selling, a little toy app or whatever, like, a calendar app, whatever it may be. Okay, that's going to have significantly less requirements, but still all these things are going to be required because they want to make sure they can protect consumers from, hey, I, installed a random application on my, PC and it stole all my data. And you talk to the company, they go, oh yeah, we had a vulnerability, but we never patched it. It's like, no, you have to patch these things because you have to protect your customers. So that's sort of why it's important. And then if we look at Guac, so Guac is an open SSF project, again, Open Source Security Foundation, which is like a sister organization to the CNCF. So the CNCF and OpenSSF both fall under the Linux Foundation, and OpenSSF is very focused purely on just general open source security. So not just cloud native security, but open source security. And so the project there it's essentially, an API and database that stores stuff like your software bill of materials, your vulnerability exploitability information through documents called VEX. It includes license information. It includes other attestations like Salsa, as I mentioned before, and collects all of that, sort of generates a graph out of it. And then you can sort of query that graph to better understand the supply chains there. And so as an example, CNCF themselves are exploring using Guac to help understand other CNCF projects, so that they can better, like a big challenge, right, at the CNCF is there's hundreds of, or I can't remember how many, it's like 150 projects underneath the CNCF nowadays, give or take. And the challenge about that is, like, what happens if there is a license issue? What happens if somebody is submitting a new thing? What happens if there is a license issue, like where somebody is using a library and the library's fine, but a month later, somebody rug pulls that library and they're still using it and they didn't realize that somebody had rug pulled it. And then somebody's, sending legal threats to CNCF or something like that, right? They want to make sure that they can understand that. Guac helps sort of build that out and also helps understand, hey, did you know that this library is used by these 20 CNCF projects? So if anything were to ever go wrong, like let's say there's a new vulnerability, maybe we can get those 20 CNCF projects all to come in a room, because there's going to be serious issues if like there is something the extent of a Log4j sort of vulnerability to something like Kubernetes, right? Because everything sort of relies on that. So what can we do to make sure that folks know what's going on and yada, yada. So that's sort of Guac, the open source bit. And then we took a lot of that and we took all of the learnings and we sort of bundled it all up into what we built out into our platform, where we manage that all for you. It's built into our SaaS, and we can essentially provide all of that. And in addition, we can sort of combine that with other data that's coming from other places. So, like, for example, we help with the runtime integration. So if you have, as an example, if you're using Kubescape, we can pull the runtime data out of Kubescape, integrate with our stuff, so you have these vulnerabilities and these are the Kubernetes clusters where they're running. So you can better understand, like, is this only in the dev Kubernetes cluster? Is this in the production ones? Those sorts of things. And so, and there's a bunch of other like stuff in there as well. Because we're tracking all of this data over time, we can build like essentially a timeline of what happened when. So if somebody were to introduce something with a bad license, we know on this date somebody actually went out and put something that had a bad license or with a known vulnerability, right? And maybe it was a mistake, maybe it was on purpose, whatever. But I think you can kind of, there's lots of those sorts of use cases that folks are coming to us with, where they're saying, hey, we don't know exactly what's running, and we want to make sure that if something were to go wrong, we have a better understanding of like where it exists, all that good stuff. And then also when it happened, right? Because for a lot of folks, we have a 30-day window to fix this vulnerability. So if a new vulnerability is discovered, that's when it starts, right? New vulnerability was discovered on, January 1st, and we have till the end of the month to fix this. Great. And we could see, well, on January 10th, a new version was built. And on January 20th, that new version was deployed. And we can see that. And then we can also kind of pull in all the additional information and say, oh, and we actually have no record of any of the vulnerable versions still running.
Okay. So, okay, we have already talked about Guac. So what does Kusari do above Guac? What's the connection between these two technologies?
Sure, yeah. So some of what I described just there, like Guac doesn't necessarily do. So Guac sort of, the way I think about Guac Guac can answer whatever question you want with whatever data you give it. Okay. Kusari knows what questions to ask. So the thing there is, again, it's just a database. It's just an API that you can ask questions about, where does this vulnerability live or whatever. But we kind of keep track of it over time. We have a better understanding of your environment. So it kind of pulls all that sort of in, and like with stuff like labeling and tagging, we understand what's there. So the sort of stuff that we're doing on top, there's a bunch of different things. One is we keep track of, additionally, like we link runtime information. We also sort of automate a lot of the collection of the SBOMs. So we have methods for sort of doing that, whether it's push or pull, like either you're sending it to us from your CI system, or we're pulling from, hey, you gave us access to some sort of cloud bucket where all your SBOMs live, whatever it may be. We do stuff like that. And, we combine the exploitability information. We also have risk prioritization based on your environment. So one of the things that we do as well is we have the concept of like a Kusari score, which is sort of a, stack ranked risk score. Because one of the big issues is if I have 100,000 vulnerabilities, that's a lot, right? What do I need to prioritize? And the way we prioritize it is around through things like, what is the criticality of this vulnerability? What is the exploitability of this vulnerability? Is it known to be exploitable? Are there known exploits for this? Is it externally facing based on the information you've given me? Based on all those things, we can then categorize for our customers, hey, this is probably really important for you to fix because it is outwardly facing. And hey, this other thing is a level 10 vulnerability that's running in the sandbox somewhere. So as long as it doesn't go beyond the sandbox, and because we have that information, we could tell folks, hey, don't use this. And that's one of the other things. And then the other newer thing that we've, been working on is sort of a way to sort of build that into your pull requests into the systems that you're kind of loading in. Because again, given that all of this is just an API, we are building out tools, which are, they're empowered through AI and stuff like that, but where we can kind of connect that data that we're pulling in to help folks understand, hey, I made a pull request, and did you know that you probably should be updating that dependency because it has a vulnerability? Hey, you're using this in a bad way, like you're using this tool in a way that could be exploitable, those sorts of things. So we're working on a lot of that as well, and then tying it also not just in there, but also into the IDE as well. Because as a developer, right, if you tell me there's a security issue as I'm writing the code, fantastic. If you tell me, hey, did you know that you inadvertently wrote a SQL injection vulnerability into your code 2 months ago? And you're like, okay, now I got to go back and rewrite, 1,000 lines of code here. Why didn't you tell me that when I first made it? That would have been much easier to fix. So we really want to help out with not just helping our customers react to issues, but be more proactive to make sure that not only are you sort of dealing with the issues as they come up, but you're making it harder for new issues to not go addressed.
Okay, so can you imagine the situation that we've got an IDE, there's a developer who is willing to prepare a PR, and you create a kind of a hook which calls the MCP server, calls the LLM, hey, please check the dependencies and how that change may work across the whole application, across the whole system. Is that okay?
Pretty much. Yeah, that's the gist of it, right? Where I think And you should be hearing more about that in probably the coming weeks. But from our end, I think there are some really cool things that are kind of coming out with this, right? Where I think the thing that we've realized is, AI is great, but one of the things it's not good at, it's really good at hallucinating a lot of stuff too. So you really need to make sure that you provide it the right information. And that's where we think we are coming in with some cool stuff is we have that information, right? We're integrated into all these open source and other sort of databases. We're pulling in all this information from things like license information from Clearly Defined and vulnerability information from places like OSV and other places. And exploitability information, all this information, and we can kind of tie all of this together so that you have a better understanding of like what needs to be fixed, what needs to be addressed as it's happening. And in addition to that, right, long term, we can pull all of that in with the other information we have about your environment, right? We can probably tell you that, hey, this is an issue, but we know that this is probably an issue that'll be addressed in Sandbox. So we're not going to like tell you, oh my gosh, this is terrible and whatever. It's like, but if that same thing, we see that same thing, hey, this is a pull request to now deploy this to prod, we can tie that all sort of together. And that's kind of the direction we're moving. We have obviously elements of that today, but we should be seeing sort of elements of that in the future as well, where again, the story we want to be able to tell is two things. One is we want to be able to say for your CISO can be in a meeting, the next log4j happens and he leaves the meeting without, his phone's off. And it's like, oh, it's already been addressed, right? Like not necessarily everything's been fixed, but the plan for it is there, right? They know exactly what needs to be fixed, where it needs to be fixed, what, source repos need to be updated, what new builds need to happen, what new deployments need to happen, where do they need to happen? Hey, great. Your CISO's happy. He's not worried about the company going under. He's not worried about being under scrutiny from legal authorities, all that good stuff. And then separately, like as a dev, great. I can go home on time. I don't have to like get called in on the weekend being like, oh my gosh, everything's on fire. We all got to fix stuff because, when you go in, you're like, oh, I didn't realize this new crazy vulnerability happened. You could just go say, okay, well, I go into my, requirements.txt, my Maven POM file. I go to add the bad dependency because I didn't realize, and it has the little red squiggly. And when I run, my build, hey, it goes and says, look, this would build, but we want to block it because there's a problem here that needs to be addressed. And then you go, oh, okay, cool. And you just update to the later version and, you're fine. Now, again, obviously it's not always that simple because with backwards compatibility and sometimes little issues with, oh, this minor thing changed this other thing and that kind of has other issues. But we think solving most of those other ones makes the actual ones where you have to think about backwards compatibility. Okay, let me focus on that, right?
Okay.
I don't want to focus on the little like, oh, whoops, I forgot to update, stuff like that.
All right. And well, if you could, let's assume that I'm a huge enterprise company. We have 300 projects. Each project has 3 teams, 7 people in each that are working around the sun. Each of these projects present totally different technologies. We have Golang, we have NPM projects, we have a lot of the dependencies, centralized platform, actually on a few clouds, including on-prem stuff. And well, we had a really huge breach. That's, for example, in UK, there was a huge breach for Mark Spencer and our staff. They had really hard time last month. And well, I need to introduce something to manage my dependencies, but I have a lot of dependencies. For example, I've got an IoT department, which is producing lawnmowers, and they have their own package management, including APT, aptly, Debian packages. We are building their own packages that have inside a lot, and they need to create their own SBOMs, whereas totally different department that takes care of front-end packages. Okay, I'm a CISO of a really huge company. I'm in hell right now because I may lose my job because we are losing $30 million per day. Save me. How to make it very fast? How should I start?
Yeah. The way to think about it for us is like, we're here every step of the journey, right? Like for you. So if you were to kind of say, hey, Kusari, a lot of folks, there's, Could somebody go out there and pick a bunch of different open source, write some code, and kind of create their own sort of custom solution? Absolutely. A lot of folks can do that, but a lot of folks are like, I don't want to do that. That's expensive. I have to hire a team. I have to have a team that manages that, yada, yada. So that's where we think Kusari comes in, where we're there sort of every step of the way. So the idea behind it, right, is if you have SBOMs that are not great, it's better than nothing, right? We can get you started there. And some of that maybe requires a little bit of manual labeling to make sure that you are telling us, oh, this is an SBOM for an IoT device that's deployed in wherever. Like, okay, great. Then you can go back and filter some of that. But then over time, as things get better and you fix some of these things, and this is again where we're building out some of these tools as well, is we're trying to build out more tools to also make it simpler for folks. So we do have a suite of like tools to automatically help generate SBOMs. And again, it's mostly using stuff that already exists, but in trying to understand your application and whatnot. And for a lot of folks, I think it really comes down to is your average developer, your average DevOps, your average security engineer doesn't want to become an expert in SBOMs, right? They're just like, no, it's a means to an end. So what can I do to just kind of add that in and then kind of move along? And so that's kind of where we're coming in a little bit as well to sort of say, hey, you're starting off, your SBOMs are not great. We can help you in two ways. One is we can do the best with what we have, help understand where your vulnerabilities are, but also indicate where there might be deficiencies and provide both manual and automated guidance on fixing that, right? Improving it. So again, like in my opinion, an SBOM that happens at build time is much better than a SBOM that's a scan after the fact. And the reason why is the build knows what's being pulled in, right? The build knows I'm pulling in this dependency, I'm pulling in that dependency, and I'm actually including it in the binary, or I'm dynamically linking it, or whatever it may be. But then when you have the scanners, the problem with a lot of the scanners is they often miss things because they don't know that the binary has this random included static dependency because it just doesn't know how everything's compiled. It can't really infer that. And then in addition to that, a lot of the ways that these other scanners look at this is they'll look at the database, like the package database, like your Debian package database on your VM, and pull in those dependencies, which is useful. But in some cases, when people are generating their golden image, they delete the database because it takes up space, it's an additional whatever. And then all of a sudden you're like, well, I run my scan and it says there's no packages there. And you're like, well, actually there are a bunch of packages, but it doesn't know how to look for them. So there's a lot of like challenges there as well. And so we're trying to say, hey, here's kind of how you sort of flow all of that in over time, and providing, through our, new PR tools that are coming out very, very soon, and stuff like that, you will be seeing that, hey, we're there to actually help sort of guide you through that, so that today you're very reactive, but tomorrow you could be more proactive. And so, yeah, today your CISO is like pulling out his hair and super worried about what's going to happen. And then tomorrow your CISO is like, oh, cool, like everything's just being handled. There's a process for this in place that if a new project comes in, it automatically gets the best SBOM it can get. The existing tools are already, the existing projects are already being retrofitted with better mechanisms for that there. And if you were to ask me, like, what's the one big challenge there? It's every project, as much as you think they're not special snowflakes, every project is a special snowflake. Every project is like, even anything beyond Hello World, right? If I have a Go project, oh, well, this Go project generates, this Go project also includes some Docker files because that's how we distribute it.
Yep.
Well, some folks, that's one repo. Some folks, that's two repos. Some folks, that's like a mono repo with alongside every other project they ever have. And that can be very complicated when you're coming in and saying, okay, well, how do I generate an SBOM for this? Am I generating an SBOM, one SBOM per repo, one SBOM per project? What counts as a project? That sort of thing can be kind of complicated because, again, every single company does it slightly differently. And getting folks to sort of do reasonable things in that can be pretty complicated.
Okay. So to not waste your time, because, well, we are talking 45 minutes, let's be honest, but if we could create 5 points, let's assume that I'm a CISO, I don't have any security, I paid a lot of money for Datadog, I paid a lot of money for CrowdStrike, for a lot of tools.
Good for you.
Exactly.
With CrowdStrike, right?
And well, I got a lot of criticals. I paid a lot of money for an audit from Deloitte, Accenture, and then any other company. They told me that I suck. Let's be honest. And they told me you need to fix that approximately 60% of all criticals. Otherwise, you will lose your insurance, your cybersecurity insurance. And I come to you, and I need 5 points. Strict 5 points, how to start and how to fix the situation, assuming that most of the issues are vulnerabilities in my applications. Let's assume that my network security, cloud checks, and other stuff are fine. Let's focus on applications and vulnerabilities. How would you start?
Yeah.
5 points.
Yeah, sure. The first one is know your dependencies. So
Okay.
that's the first one, right? And that is generating SBOMs, running in cases where maybe you can't run that. Hey, there's lots of other scans out there that can still give you, SaaS scans and whatever that can do that. The second one is know how you're using your dependencies, and I'll include general sort of software like scanning. So like your sort of Sonar Cube and that sort of thing of like, hey, let's scan the software, your SemGrep or OpenGrep, that kind of stuff of like, are you including SQL injection attacks or other sort of like you're not sanitizing your inputs, those sorts of things. Because again, that's where the way a lot of folks get in is through like the simple mistakes like that. And so that is sort of the second point. A third point, which I think is like, it's not technical, and maybe this is point one actually, is more of it needs to be funded. Way too often there is this thing of, security, because it is not the thing that's making money, right? Security is not the thing that, gets you the VC funding. It's not the, oh my gosh, I have a new AI tool that is gonna blow everybody away, and it's a multi-billion-dollar company right out of the gate. It's like, no, like, but the problem there is, hey, that AI company still needs to secure themselves. And a lot of times you don't want to spend the money because, hey, that's money that could be spent on building that product and getting it out the door to the customers. So really, I think that's the number one point, is like really making sure it's funded. 2, SBOMs. 3, sort of SAST and those sorts of things of like, hey, actually look at the code there. I think that there's also, again, cultural shift. So I know there's DevOps, and there's security, there's DevSecOps. I think one of the biggest failures in sort of the DevSecOps movement was, I think DevOps worked in getting developers and operations to come together better, build out platforms, build out things that, hey, it's not just a developer writing some code, it gets handed over to an operator who has no idea how any of this works and is just told to deploy it. Early on in my career, that's how I operated. I very much like the DevOps focus now. And I think that sort of thing is huge, because security is still seen as they're the gatekeeper. But at the end of the day, security, like, it's all about risk. So how do you sort of manage these risks and understand that maybe it's okay for these minor deficiencies to go out for the marketing website because it's not the crown jewels, it's not the banking application. And getting those, getting security to be seen less as a gatekeeper and more as sort of an enabler here, right? They're there to like essentially make sure that everybody goes home, make sure that everybody keeps their job, make sure that their CISO stays out of jail, all these things. And let me think of a fifth point here. Like, I think I think the other thing, I think the fifth point is what I call the SDLC control plane. This is very, very early on. A bunch of us in a bunch of different places are talking about the need to, and again, this is something that we believe to be a pillar in the future, but maybe not there yet, is the idea for really understanding end to end the flow from a developer has an idea, starts writing some code, to that code is now in production, running in production. What are all the things that happen to get there? And how was that sort of stewarded through that process? Similar in a way to Kubernetes. Now, the challenge a little bit with this sort of thing is, whereas Kubernetes, state is managed in etcd. How is your state managed for your project? Well, you have your code in, let's say, GitHub or GitLab or Bitbucket. You have some state on a developer's workstation. You have some of the state that's managed in your build. You have some of that state that's managed in, maybe you're using Sonatype Nexus or Artifactory or some other mechanism to store, like an OCI registry or whatever, to store your artifacts. And then when you're actually running the stuff in production, you now have, however you're running it in production is also some of that state. And how do you sort of manage that in a way is super important, because too much stuff is shadow IT, right? Too much stuff is, how did that application end up in production? Like the Kusari platform only does what you give us access to. So if you have a secret set of folks who are not building SBOMs, who are doing something on the side that we have no visibility into, we can't magically tell you, hey, we can magically tell you there's a bunch of stuff here that seems like we don't have any information on based on what we've seen, but we have no way of really kind of providing a bunch more of that information. And so we really need to have this way of saying, from developer to runtime, we have an understanding of everything that's going on, because then you can build in the policy as code. You can have the OPA and Kyvernos and all these other things to sort of steward all of that through there. You can have the policy that says, if there are vulnerabilities, it just doesn't go to production. Like the policy as code is there. You can have the thing of a developer's code isn't even allowed to get pushed as a pull request if there's a critical issue there. Like, hey, we noticed you're trying to push a secret. We're not even going to let you push it as a PR. Like, it just won't block it. We'd love to have that in the future, and we need to start moving in that direction. So I think that's kind of like the final pillar, is really understanding your end-to-end SDLC, because in the future, it'll make everything simpler.
And the sixth element will be install Kusari, right? What you said is very important, because we can have like a theoretical understanding of our SDLC using, for example, value stream mapping and value stream management, right? And we have like shuttered tools to create a visibility of some parts, but having this like a one platform would be amazing.
Yeah, I think the challenge a little bit there is it reminds me of the like Mesosphere versus Kubernetes thing. Is like Mesosphere is like you could pick and choose a bunch of different things, and Kubernetes was the one that won because Kubernetes is just like, hey, it's all in one, right? Like you don't get to choose what your state management is. It's etcd. You don't get to choose, like there's a couple of container runtime backends, but for the most part, it's only these three things. Like whereas Mesosphere and all that, you had like whatever you could bring whatever you wanted to the table. I think the challenge with a lot of this is, to be clear, Kusari will have what they are coming in with, but the challenge a little bit there is folks will say, well, some of my devs use VS Code, some of my devs use, I don't know, whatever else, like Vim and whatever, and some of some of our code's in GitLab, some of our stuff is in OCI, some of our stuff is in GitHub releases, some of our stuff is all over the place, and I think the challenge there is we need to figure out ways to make all of them speak similar languages. That to me is, I think, the number one thing, because then you can build that overall platform. Because if all of them communicate in a similar API, then you can say, hey, all these events that are coming out, they're all the same, right? A GitHub source commit event should be the same as a GitLab source commit event, and your system should be able to kind of pull all that together as well. And so there's a lot of projects that are starting to build that out. There's one called CD Events, which is a refinement of cloud events that came out of CNCF, and that one is in the CD Foundation. Yes. So there's a lot of stuff that is being used, but I think it's going to be a long it's going to be a long process to kind of get everybody aligned.
Oh yes, I have a lot of things to think about. after what you said. Yeah, that was really great.
I agree.
Rafał, anything else, because we are running out of the time. We don't want to keep you for longer, but we are able to, really. So maybe the next episode is in order in some time to discuss more about those things, and
Sure.
maybe with some platform demo. So the last question is how the ordinary folks like can we start with Kusari platform?
Sure. So for the ordinary folks, I think the thing is, give it a couple of weeks. The hour thing that we are we'll be releasing here in a couple of weeks here, and I don't know exactly when the podcast episode will go out, so it'll probably be out maybe by the time this goes out. Is there will be a if you're on GitHub, there will be a pull request bot that is enabled through the Kusari platform. And, if you are just the average developer, your small team who can't afford the full-fledged Kusari platform, you can still get a lot of the benefit out of that through the our sort of AI empowered bot, where again, the AI itself is not going to be, it itself is not doing most of the heavy lifting. It's actually a bunch of scans that we are running on your source code ourselves to understand your dependencies, pull in the data that Kusari has sort of collected and analyzed, and help understand are you, for example, pulling in are you pulling in a secret, and in fact then doing the additional analysis on that secret to understand, hey, it'd be really bad because like the big thing here is too many false positives, right? Too many folks are like, this is clearly my test code. So even though it says password, it says test password. We're sort of doing that additional sort of analysis to understand, is this something that is actually a concern? Hey, there's even vulnerabilities that we say, look, there's a vulnerability in this PR, you should probably fix it. But according to our analysis, it's actually not exploitable because of these reasons. That sort of stuff is going to be coming out quite soon, and that will help sort of the smaller team. And then as the team grows, and you need to start saying, okay, well, we don't just have 1 or 2 projects. We now have 100 projects, and we need to understand those 100 projects and how they all interoperate. That's when you can then sort of seamlessly transition to the Kusari platform. And again, this bot that we have will also make it very easy to automatically start generating the SBOM for you, not through not having an AI try and figure out your SBOM, but more have the system go in and figure out how your project is structured and know what SBOM tools need to be run with what flags to actually generate the best SBOM for your project. And then that can then seamlessly flow into the Kusari platform so that when you start to grow and grow and grow, now you can start to answer the questions, not just, do I have a vulnerability, but where's the vulnerability come from? And oh my gosh, that vulnerability, if I'm Alice and Bob has a vulnerability, if I'm using Bob's library, and Bob's library is the thing with the vulnerability, the Kusari platform can tell you, hey, look, you can't solve this. Bob has to solve this. And the Kusari platform has already told Bob, here's how he solves it. And then once Bob has gone out, deployed the new version of the library, we can automatically open up a PR and yada, yada. So those are the things that are sort of coming out pretty soon.
So there is something to wait for, right? So
yes.
Please, guys, observe the kusari.dev webpage. Please observe what's going on in the repositories and be alerted because changes are coming soon.
Well, okay. No more questions. Thank you very much. That was awesome.
Yeah, it was awesome. Huge. It was great to talk with you. And we are happy that you are okay with having another episode with us.
Sure.
Thank you very much, Mike. Our guest today was Mike from Kusari. We spoke a lot about SBOMs, a lot about security, and we will have a lot of more questions very soon.
Definitely.
Now we can switch to Polish and finish this episode. Także dziękujemy wam wszystkim za ten odcinek. Jezu, jak to dziwnie brzmi teraz. Widzimy się niedługo w następnym odcinku. Chcę to skrócić jak najszybciej, więc trzymajcie się, do zobaczenia. Cześć.
Trzymajcie się. Cześć.